Hello, this is Engineer Dan and welcome back to another video. Today it's going to be a geography video on tectonics and convection currents. I am going to stand up in a minute, that's why we are in a little bit of a different place, just because I have a map above me telly, but we'll get on that later. So the objectives of today is to know about the 4 different types of plate boundaries, what hazards each plate boundary creates, and finally, what makes the crust move. So behind us, as you see, I have my whiteboard with a diagram on. Now this diagram shows the structure or infrastructure of the Earth. I have a core, an outer core, a mantle and a crust. Now the asthenosphere and a lithosphere, we don't really need to know that, especially in the test that we are going to be doing, I think, in a few days. Now the crust though is probably a question that's going to come up, and there's 2 different types of crust, oceanic and continental. Oceanic crust is a lot newer, a lot less dense, a lot more dense, so oceanic's heavier because of the rock basalt. However, on the other hand, continental crust is a lot lighter, it can't be renewed, and that's because it's made out of granite. So oceanic can be renewed, a lot more dense, continental, not that dense, and cannot be renewed, so it's older. Now, this theory all came about, this convection current theory came to surface at around about 1960. However, before that there was a man called Alfred Wegener who saw the map and figured out that it looked like a piece of a broken puzzle. And he called this continental drift. He didn't really know how to explain what was happening, so all of his fellow scientists thought he was going like loopsy, but he wasn't. But yeah. So Alfred Wegener is kind of the founder of this concept and idea, and it did get backed up by new scientific equipment called seismography, I think it's called, and that's using P&S waves. But then again, we don't need to go into that, so I won't go into that. So what happens is in convection currents, molten rock gets heated up by the outer core and core, mostly core. It gets less dense, so it starts to rise. So when it rises, it reaches the top, cools down, and comes back down. Gets reheated, goes back up, gets cooled down, comes back down. So less dense goes up, more dense comes down. It gets less dense by getting hot, and it gets more dense by getting cool. So that's basically what a convection current is. And this happens in the mantle. So this got little 2 convection currents here are pulling this crust apart. I mean, we'll get on that in a minute. That is called a constructive, a divergent plate line, what is also known as a constructive boundary. The theory that supported Alfred was that fossils look like the same, but those from totally different continents. So as you see in South America here, he found fossils that looked a lot like fossils from Africa. And as you see, my little diagram, not an artist by any stretch of the imagination, but yeah, look at the diagram. So, let's just take that board off. Now, these are the 4 types of plate boundaries, and I'll have to probably kneel so you won't be able to see us, but I will be still here. So, our first plate boundary is divergent and constructive. It's a divergent plate line, and this is called a constructive plate boundary. Now, these 2 plates move away from each other, allowing magma to seep up through the crack that it creates. This creates a little shield volcano / mountain-esque thing, and the more that the plates get further apart, the more magma can get up through the little gap, meaning the bigger the mountain or shield volcano will be. This is the sea, and if it gets that big, can rise above the surface, like what Hawaii is. Hawaii is basically a big island built on a constructive plate boundary, or something similar to that. Now, next one we'll have a convergent or a collision. This is one of the convergent plate boundaries, and it's called a collision. Collision is when 2 continental crusts go head to head with each other, and then the only thing that they can do is rise. So this creates a mountain range. Nothing really exciting about that. Moving down to the second convergent plate margin, or also known as a destructive plate boundary, is, well, destructive. It's the most destructive, in my opinion, out of all four. However, that is up for debate. But as you see, the oceanic crust goes head to head with the continental crust. Since the oceanic crust is more dense, then it starts to sink. The oceanic starts to sink. Now, this little bit here underneath the continental crust, this bit, is called the subduction zone. Now, this subduction zone just means that this is where, how it's newer, oceanic crust is newer, it goes underneath and then it starts to melt and goes into the molten rock that gets supplied somewhere else, maybe in constructive. Or it gets remelted to make another bit of the oceanic crust. So, the quick recap, oceanic goes under the continental because it's more dense. This is called the subduction zone. Subduction zone, the oceanic crust starts to melt and it goes back to form oceanic crust. Our fourth and final plate boundary / margin is a transform margin, also known as a conservative plate boundary. And this is when the two plate boundaries slide past each other. They could be going the same way, just at different speeds, but ultimately it causes earthquakes. Now that brings us nicely on our got last little bit here. This is all on paper because I couldn't find another whiteboard. So, collision. Collisions is examples, Indian plate plus Eurasian plate. In a moment I will stand up and show you me map, since you don't need to watch that anymore. I might as well just move it back a little bit. So, yeah. And the effects of a collision is it causes earthquakes and mountain ranges. So, like the Himalayas is a good example for a collision plate boundary. Earthquakes, by the way, is sudden, intense, but short period of time where the ground shakes. As long as you have sudden, intense, and short period, you should get that right. So, moving on to our second plate boundary is called a conservative. Examples is the Pacific and North American plate. And I've just realised I have spelled Pacific wrong. I was in a rush to make this. And the effects of that is earthquakes. Now, a good example of a conservative plate line is the Andreas Fault. That is in North America, by the way. Moving on is our constructive plate boundaries. And examples of this is South America and Africa coming together to make the Mid-Atlantic Ridge, and the effects is a shield volcano, islands, or island arcs. Finally is our fourth and final boundary, and this is destructive. Examples of this is the Nazca plus South American plate. This causes the Andes as well. And the effects of this is volcanoes, marine trenches, earthquakes, and mountains. So now, you know all of that. I'm just going to point them out on a map that I have. I knew this map would come in handy. Sorry if you can't really see that well. It's just because my light is. But